Alrighty, hello everyone. So today we're gonna go over quite a few things. Mainly, we'll start with an example that's analogous to um, our portable testing chamber frame. We'll start by doing an analogous example, and then we'll move on to actually making modifications to our portable testing chamber frame. Then we'll end off with showing how to we'll end off by reviewing how to slice and Cura and getting it ready to print on the 3D printer. So let's start with the SolidWorks environment and with our analogous example. All right. So just to make things easier for ourselves, hover your mouse to the left hand menu panel. Over here, you have all the components of your potential part, right? To make things easier for yourself, right click or left click on the top plane. You'll see this eyeball as well as a small flag, a small label that says show. You hit that, you click, left click, show, and now you're showing the top plane. So that's what we'll use to make it easier for us to basically visualize where we're drawing on our environment, in our environment. So then, very simply, left click on the top plane, hold down Control and then 8. Control 8. And that'll bring your vision normal to the top plane. So once you're normal to the top plane, we can now more easily uh, create our sketch. Our sketch will make more sense to us. So let's go into sketch. So go onto these menu ribbons on top. As you can see here, there's a sketch ribbon. Click on the sketch and hit sketch. Alternatively, you can also right click on the plane itself and hit sketch in the menu pop-up that occurs after you right click it. So once again, you right click on top plane and do the sketch feature, sketch tool. You hit it, perfect. So now we're on perfect pace. All right, so as you can see here, now we have a sketch. As you can see, it's below this gray line. It's below this gray line because it's not fully created yet. It's in the process of being created. All right, so let's put some shapes down onto this plane to create our sketch, our 2D sketch. So to do that, let's simply use this tool called a corner rectangle. So left click on this corner rectangle tool. All right, and it doesn't quite matter the exact dimensions. Basically, you click to place down one corner of the rectangle, then you can stretch it out. So you click once to place down, you click once and let go to place down a corner, and then you can move to wherever you want. And then by left clicking, you'll drop down the second corner. And by using those two corners, your rectangle will be defined. There you go. Now, following suit, pick one of these corners. I'll pick this corner and do the same thing. It doesn't need to be the same length, like that. Okay, so let's do this again. Left click on this corner, as you can see. It will automatically bring my mouse. It will automatically select this corner because it assumes that I want to start in that corner, which I do. So left click to drop a corner of the rectangle at that location, drag, or just move your mouse without not dragging, because all you can do is click once to place, move it to wherever you want to place the other point, and then click again to place. So I'm going to drag it all the way out here, place. And to escape this tool, I believe you can click it again, and now you're back to your mouse, your pointer. Or alternatively, you can always hit escape. The escape button will always cause you to exit from the tool back to the pointer tool. All right. Something else that's very useful is to orient yourself in the environment. It's crucial that you have a mouse. Having a mouse is crucial for CADing, for doing CAD, right? Holding down the mouse scroll wheel allows you to adjust the angle of view. Whereas holding down Control and then the mouse wheel, so your mouse wheel can click, or you should be able to click. If it clicks, if you just click the mouse wheel, you just change the view. But if you hold down Control and then click the mouse wheel, you translate your view. So your entire view moves, translates in the plane of your sketch, or in the plane that you're currently in. So once again, mouse wheel click to rotate or to change the view angle. Control mouse wheel click to translate it to wherever you want. So those two are very important commands that you should use very frequently in the future. All right, so now something that's very crucial as well, uh, as you should have seen probably in the SolidWorks introductory video. There's a tool. If we go into Sketch, which we're already in, you left click on Smart Dimensions. This is like the bread and butter almost of CADing. I'd say the bread of CADing. The butter is something else, which we'll cover way later. But now you can select, as you can see here, whatever you select, it will highlight. So let's say I want to smart dimensioning. Smart dimension, as its name entails, it's a really smart, it's a really efficient way for SolidWorks to put in dimensions for you. It's very intuitive, or it's supposed to be rather. So let's say I want to change this dimension, right? The dimension of this line right here that's highlighted in orange. I click on that line, and now I can choose, let's say I want it to be 5 millimeters. So now I've set this bar, this line here, to be 5 millimeters. All right? Let's say I want this bar here to be, 100. Same thing. You will place down, here, let me do this again. Control Z, Control Z. Control Z is to undo. Control Y allows you to redo, to undo the undo, if that makes sense. All right. So once again, with your smart dimensioning tool, you can click the top bar, left click once, and you'll see a number. Left click again to drop it at a certain place. You can still move it from that location. Enter whatever value you want. It can both be millimeters or in inches if you want. In this case, just to be consistent, millimeters. You can always drag this around a little bit just to place it somewhere more aesthetically pleasing. But for now, this is what we have to worry about. And of course, you have to add in a lot more dimensions. We're just going to leave this here for now, okay? So after you finish your sketch, after you finish your 2D sketch, you want to hit this save, I think exit or save and continue, or exit, save and exit. So the blue one is save and exit, whereas the red cross is just exit. If you hit the red cross, our progress will not be saved at all. Our sketch will just disappear, and we won't get it back. So this is what you click, either by accident, which happens sometimes, or when you're really dissatisfied with your sketch and you just want to restart. But for the most part, we're satisfied. So I'm going to hit the blue symbol to save and then exit. Now we have our sketch. So from a 2D sketch, the overall workflow of our CAD process is to create a 2D sketch and to use these various other tools, such as extrude, to pull, rotate, somehow like flip, mostly pull though, these 2D sketches into 3D parts, into 3D volumes. You're pulling areas into volumes, if that makes sense. Making it go from 2D sketch to 3D volume. All right? Just to reiterate a few times, because it's a really important idea. So going from here, you can now change the ribbon or tab to features. Left click on the extruded boss / base. All right. Now click on one of these lines, any lines. Any line shall work. All right. So now, as you can see here, it will show you a preview. Right now, I'm currently holding down my mouse wheel. I am holding down the mouse wheel to rotate this thing around, just so I can see what it looks like in the context of the rest of the parts and sketch. So as you can see here, we are pulling this top rectangle here up by 5 millimeters. Let's change that it's arbitrary in this example, but let's just change it to 10 millimeters. What if we want to pull another rectangle, also 10 millimeters, right? How can you do that? Well, to do that, you go into selected contours, you hit this box here, make sure it's blue. You make sure this box is blue in selected contours. Now you can choose, as you can see here, it'll highlight red. You can choose any other region that you want to also pull the same distance as you pulled the first one. So if you click this third rectangle here, you can now see that there are two rectangular prisms. Both are from these 2D rectangle sketches that we've extruded upwards 10 millimeters into now two 3D volumes. Now we have two 3D shapes. So let's hit check to save our progress. All right. As you can see here, our sketch disappears after we make our 3D shape. If we want to use a sketch again, which we do, you open this drop-down menu. There's a lot of drop-down menus in Solidworks. So just keep in mind that a lot of these drop-down menus contain more information and important parts that you will need to use. Now, open this drop-down menu for your new extrude feature. Left click or right click on the sketch. Hit show again, just like how you made the top plane show up. So hit show, and now, as you can see here, you can see the sketch again. Similarly, you can left click or right click and hit hide to hide and make the sketch disappear again. So because we want to use a sketch one more time, we can make it show. Go back up to the feature ribbon, feature panel, feature tab, hit extrude, click on one of the lines again on your sketch. So now it thinks we want this thing here called thin feature, and that happens every once in a while when you're using this tool called boss extrude, which we used earlier. It's kind of stupid, but just uncheck this box, and you're good. Thin feature is rarely used, so make sure this is not checked. Thin feature is not checked. All right. Now I can go to your selected contours one more time. As you can see here, we can now add this little region here. But for some reason, it's not showing the preview, right? And that's because we just need to delete the first selection here. So select left click on the first feature, on the first region, and just hit delete on your keyboard. And now the second volume, the second shape will show up. So let's change this to a different height, 5 millimeters. We're extruding this middle rectangle. We're pulling it up by 5 millimeters. Now also into a 3D shape. And these three shapes will now merge into one body. All right. So once you're satisfied with what you have here, you hit check, and boom. This should look familiar because our chamber frame uses a similar concept to what we covered here. Now, let's say we want to make this little divot here, this groove in the middle. Sorry for the bad angle, but if you want to make this groove in the middle, as you can see here, this groove, this drop down in the middle, if I want to make this more narrow, we can now open this first drop down menu on the left hand menu panel. You can open this drop down menu, left click or right click on sketch, and hit edit sketch. So we're now revisiting an earlier sketch. So that is how you revisit an earlier sketch. So I'm just going to hold down Control and the mouse wheel to reorient this. Another useful tool is to use this thing called a view orientation tool. If you left click on this little icon here, you'll get a cube of the most common orientations that people will want to use. So there's top view in this case, and there's isometric somewhere. Top view, this is front view, left view, right view. So these are just the default views. So that's another tool you can use if you want to make it more easy for yourself. Otherwise, you use the mouse wheel clicking method, and then you can always do left click the plane of interest, control, and then hit 8. That will make you normal. That will make your view point normal to the plane of what you selected. All right, so now, as we were saying, we want to make this more narrow, right? Double click on this dimension that you made earlier. Double click on this dimension. You'll see a pop-up menu, pop-up window, where you can now change dimension. Let's say I want to make this slightly thinner, so there's a tighter fit, for example, of whatever that goes in here, whether that be a board, in our case, or something else, like a piece of glass or something. Want to be a tighter fit. We can change this from 5 millimeters to 4 millimeters. All right, so now we can go back out, and boom, it will show a corresponding change. It's not as clear here. Let me just hide the sketch. Left click, hide, left click. All right, so now it's easier to look at, less confusing, less lines. All right, let's go back into the sketch and make this change more drastic. Going from 5 millimeters to 4 millimeters, it's a very small change. It's hard to tell, right? Let's make it more drastic. Let's make it 1 millimeter. Okay, let's say you completely overshot the dimension. You used 5 millimeters, but it's supposed to be 1 millimeter, right? So you change it to 1 millimeter, you go back out, and boom, there you go. Your sketch will change with you. Your shape will change with you because your sketch changed. So overall sequence of events that occurred is you made a sketch and you built a 3D part, 3D volume from your sketch by basically stretching it a little bit, stretching it out. Because you built your 3D volume based on your 2D sketch, whenever you change your sketch, it will change your 3D volume. Basically, it's all linked. Your volume and your sketch are linked. When you change your sketch, your volume changes as well, as demonstrated here. All right. So that is basically it for this example. Let's move on to how you will make changes to the actual portable testing chamber frame. So let's go into the file of interest. So I've named it grooves. Naming is always important. Make sure that you name it with the correct iteration numbers, as well as with something that is very intuitive for you, at least. So in this case, this is the base of our portable testing chamber. The issue that we ran into on Thursday, if you guys remember, was that the this groove here was too tight. So similarly to what we demonstrated earlier with that very simple example, that really simple analogous example, we'll do the exact same thing here. So similarly, we'll go into the sketch by opening this drop-down menu. So we'll open this drop-down menu and try to look for the sketch, the right sketch, because oftentimes there's more than one sketch. You want to look for the right sketch so you can make the appropriate changes to the dimensions of interest. For as an example, okay, these four are all sketch ones, so it doesn't matter in this case. But I think there's a sketch set. Okay, so there's a sketch 7. If you choose sketch 7 by accident, right click and you choose edit, the changes you make here will not affect this groove width, this groove, this groove distance. So you look around and you find the appropriate, as you can see here, it will highlight the sketch of interest. Left click or right click on the sketch, edit sketch. So now, once we're in the sketch, you'll see there are many dimensions that I've placed. To find the right dimension, you can just hover over it, and you can see when you hover over the dimension, it will highlight 2 arrows as well as 2 lines that basically outline what dimension it is fixing, what dimension it is um, between which 2 lines the dimension is uh, being applied onto. So in this case, as you can see here, 0.13, or in this case, 0.125 inches is being applied between this line and this line. In this case, Similarly, 0.125 inches again is being applied between this line, this outer line, and this second line here. And these two, the reason why they're both the same dimension is because they're the inner and outer walls of our portable testing chamber base. So if we just leave the sketch real quick by hitting the save and exit, you'll see that what we just looked at was this dimension here, as well as this dimension here. We basically looked at, by changing those two, if you want to change the wall thicknesses, you can change those two dimensions. In this case, our chamber wall widths are fine, so we'll leave that be. But the thing that was an issue was that these grooves are too narrow. So when we put the styrofoam boards into these grooves, the fit was way too tight. So what you would do is double click on the appropriate dimension. In this case, it is this, between this line and this line here. So this middle area is the groove. This number used to be 0.2. I've already changed it, increased it to 0.225 inches. If this is still not enough, you will also have to go back in here and change this to a slightly even larger value. So you would just double click, put in the appropriate, let's say, oh no, like 0.25 or something, and you hit check. As you can see here, it shifted the sketch, and when you save and exit the sketch, because you made a change to the sketch, your sketch will result in a change in the shape, in the 3D volume. All right, let's Control Z because I'm satisfied with this increase, with this value, sir, with this current value. So save and exit, and now just hit Control Save. So once you make the satisfactory changes to your parent, this is a parent file, right? Once you've made your satisfactory changes to your parent file, you can now go into the daughter files, or the like the dependent files. All right. In this case, our parent file is called grooves. Our dependent files are called grooves split 5-2 and grooves split 5-1. So grooves split 5-1 is the larger portion of the portable testing chamber frame. The reason why I split it into two different parts is because otherwise it wouldn't fit onto the Ender 3 Pro, unfortunately. All right, so now we have this. You'll have to resave, actually. Control S one more time. Same thing with grooves split 5-2. So let's left click or hover over SolidWorks, move and find left click on grooves split 5-2, Control S as well. Now that you've saved both of these dependent files, you can go into Files, left click on Files, left click on Save As, and then left click on Save As Type. So left click on this drop down menu here, change this from .prt, .sldprt, change that to here, .stl. This is what Cura will actually read. Cura will not take a .prt or .slprt file. It will only take .stl. So you will hit save, and then you will have your STL files for the base. Now, we'll do the same thing to the top portion of the portable testing chamber frame as we did to the bottom base part of the frame. So let's open up the parent file for the top part, which I've named conveniently crown top. So this is the top of the portable testing chamber frame. Similarly, you have to find the right. Similarly, there are grooves in here. So you have to find the appropriate feature, the appropriate drop-down menus here. So you gotta open all of these and find the right sketch. In this case, let me check if it's one. Let's go into sketch one. So right click, edit sketch. sometimes it's hard to tell whether or not the sketch is associated with what you're interested in. So to make things easier for yourself, what you would do is just stare at it really hard, stare at like the area of interest that interests you very hard, focus on the area that interests you for the sketch, and then save and exit from the sketch. Because what happens is the file will rebuild. The view will change from the sketch view into the parts view. So once you leave the sketch environment, it will change from the sketch view to the part view. As you can see here, this first sketch only defines this outer rim here, and that is not our groove. That is not what we're interested in. As you can see here, sketch 1 is not the right sketch. So now let's move down to a different sketch. Let's try sketch 3. Sketch 3 is this perpendicular cross here. That's not right as well. Let's try sketch 6. Okay, so sketch 6 seems very promising. Let's open up sketch 6, edit sketch. As you can see here, this is what we want to see. I've already made changes to these as well. 0.225 inches, 0.225 inches, and over here, 0.225 inches. So this sketch here, sketch 6, is the sketch of interest if you want to change the width of the grooves to fit the styrofoam boards. All right. So once you're done, once again, hit Control S to save the parent file, and you open up the daughter or dependent file. In this case, I've named it Crown Top Split 5. All right. Once again, like before, you also need to hit Control S before you go into File, Save As, and save it as an STL file. Something that you want to check before you save everything is to go into Evaluate. Go into this Evaluate tab, left click, and left click on Measure. Now you have the ability to measure between surfaces and points, as well as edges. But I'm interested in measuring between planes, between surfaces. So I want to make sure that this distance here is actually 0.225 inches. To do that, I choose this wall here and choose the wall here. And automatically it will give me the normal distance between these two parallel planes, in this case 0.225. This means these two planes which define this groove is the correct dimension. To select a new set of faces, left click in a blank part of the environment. That clears out your selection. Now I can do the other side, 0.225 inches, perfect. Left click in a blank space and you're good to go. So it's good to double check by measuring before you save it as an STL file and put it into Cura to slice. The concept is, once again, measure twice and cut once. Measure twice so we can just print it once without having to reprint everything because you made a small mistake in these numbers. Because sometimes dimension changes won't save. You might not have saved something correctly or entered something correctly. And just to be safe, you want to have different layers of like proofing built into it, into your workflow. All right, so now let's go into Cura, and I can open your STL file. So let's just do one for this part. We did grooves together, so I'll do the crown for now. So to do the crown, you'll drop it in here first. Use the different tools given here on the left side. R for rotate, T for translate, and a few other ones that you don't use that frequently. So for this particular part, it requires some tricky maneuvering. You have to first rotate this around. Oh, Control Z, rotate like this, and then rotate like this. Oops. There we go. So you want to have the tall leg in the z-axis. This is a z-axis, and one of these two is the x and y. All right. And this origin here, if you remember, this origin is always, at least for the Endo 3 Pro in this environment, always the front left corner of your build plate. So in this case, let's change the Z position to 0, so it's sitting flat on the build plate. As you can see, this will fit just fine. But I prefer to have a little extra space on all sides. I don't want to build from one end of the build plate to the other, just because sometimes there's unevenness to the build plate. So I want it to be as in the middle as possible. I want like some space between your print and the edge, if possible. So what I do as well sometimes is I rotate this shape here and print it out like this. Although, now that I think about it, either way works just fine. All right, either way works just fine. For some reason, I've always rotated it Control Y, Control Y, Control Y. I've always rotated it a little bit just so I guess there's more space between these corners and the side of the build plate. Or at least that was the idea, at least. I think I rotated a little bit more, like this. So there's, see, sort of like one block here, um, one or two blocks here and here as well. Two blocks here, one-ish, almost one block here. All right. And by one block, I mean like one grid on the build plates. So now you can hit slice. I went over this on Thursday as well. There are tutorials of how you would set up your prints. In this case, we do want support because here there's an overhang. If you notice, right here, there's an overhang. And then right here, there's an overhang right here. For the most part, not SolidWorks, Cura will highlight at least in the prepare section, prepare, preview, monitor, right? In the prepare section, it will always highlight or color code overhangs with red. Everything else will be in yellow. So once you slice and hit preview, okay, so I didn't hit support, whoops. So generate support, check this button, check this option. All right, so now, as you can see here, it's once again color coded. Red for the walls, yellow for like the roof, and the top and bottom are yellow. The walls are red, and all supports are blue. So you can very clearly tell which parts of the print are X's, basically not part of what you designed. All right, so this is something you remove. This outline here is something you remove, and this big piece of support here is what you would remove afterwards as well. And then you would name it something intuitive to yourself once again, intuitive to you as well as logical in accordance to the part that this came from. So just to be consistent, because the part was crown split, I think 6, I'll change this, for example, to maybe CRWN-6, just to make it short and simple, but still I can basically retrace my steps in the future. All right, I think that is basically everything. Went over an analogous example of how you would modify, how you would make a very simple part in SolidWorks, how you would modify um, a similar example to our portable testing chamber, especially in the case where your foam boards are either too loose or too tight. So hopefully this clears some things up as well, and offered some useful tips for using SolidWorks and using Cura. and let me know if you have any more questions. Thank you.